So I just want to break down nature of roots because some students don't understand what roots are in the case of the graph, and I just want to break it down for you. So we've all heard of this thing called the discriminant. The discriminant is b squared take away 4ac, and b squared take away 4ac is in quad formula. It's actually under the square root. So that's the discriminant. What does it look like in terms of the graph? Well, if that discriminant is greater than 0, that means that I have two roots, or, in other words, two x-intercepts where the parabola crosses the x-axis. If I have that discriminant equal to 0, that means I only have one x-intercept, which means that the vertex, the lowest or the highest point, hits the x-axis one time. One x-intercept, one root. What if I have the discriminant negative, less than 0? That means the parabola never hits the x-axis. So that's what this discriminant nature of root stuff means for the graph. So it either crosses twice, one time, or no times at all. With that said, why is it that this discriminant is so powerful? Why does it matter so much? It all, again, goes to the quad formula. Here is the quad formula, and notice how that discriminant b squared minus 4ac is under the square root. Obviously, in real numbers, you cannot square root a negative. Therefore, you would have no solutions, no roots, no x-intercepts, if that number is negative. That's what explains the red part. What if it's equal to 0? What if I have this situation where I just cross the x-axis at one value? Well, that means that this guy is 0, which means that the root essentially goes away, but so does the plus minus. So there goes my two answers. And I only have one answer, which is negative b over 2a. And negative b over 2a is actually the equation of the axis of symmetry. With that said, there's only one answer if the discriminant is equal to 0. So what happens if I have the discriminant equal to a positive number? Now the plus minus does apply. And when it does apply, I get two roots. And so that's the nature of roots.